Exciting. It's described in RC 7489 for those of you who want a deep dive. It's domain-based message authentication, reporting, and conformance. So it's really exciting stuff. Most of DMARC is actually technical, but what it adds is it's something else than a technical solution. I lost the signal there. Nope. Oh, there it is. Who am I? Sign out in the real world. In the analog world, my name is Dennis. On Twitter, I'm at signoutdk, and there's a Geek Code blog you can see if you download the PDF or view the presentation afterwards. This is what I'm going through, a quick background, who can use it, overview, status, why is it important, and how does it work, and I'll mention a couple of tools to do it. The background is that in the beginning there's no money to be made of spam from spam because you couldn't use the ARPANET commercially anyway. And up through the 80s and 90s it increased, of course. I mean, I think around 2010, 90% of all emails was actually spam. You had to do something about it. Who can use DMARC? Everybody. Should they? Yes, of course. This is the standard mail delivery. Someone composes and sends an email. Sending mail server inserts the DKIM header. It is sent to the receiving mail server. Then you do the standard validation tests of block lists, reputation, rate limits, and whatever. Then you come into this exciting green box that actually is the DMARC policy, where you retrieve and verify the DKIM. You validate the SPF, and you apply a policy, which can be pass, quarantine, or reject. And the different parts is the SMTP part, you know, where you type hello and mail from and stuff like that. That's covered in RFC 5321. That's the SPF. 5322 is the DKIM part. It's a message header, like the content of the email. So that's actually what your most mail clients are showing. So it's important to distinguish between the envelope and the actual letter if you're doing debugging in this case. But if you need to do debugging, you'll probably figure it out. But keep that in mind if you're ever in that situation. The current status is that it's working fine. It's implemented in most of the MTAs. RFC is from 2015, so it's 5 years ago. It's implemented basically in all mail servers you can find. It's in the process of becoming an IETF standard as well. And it's important because it's for the business, it provides better protection of your domain, and that's probably what you can use as a selling point if you need time to implement it. And the second importance is that it allows you to monitor and collect reports on the attempted abuse of your domain as an email sender. And if you have ever tried implementing SPF and DKIM in a large-ish environment, you'll know that you're working mostly blindfolded, and this is where DMARC can actually help a bit. It works in the way that you have your SPF record, and don't do it like this because it has a plus all, which basically means fuck you, I don't care. It just anybody can send on behalf of this domain. Also, don't use this tilde all because that's kind of a I don't know, I don't care. You have to decide yourself. It's somewhere between neutral and fail, but you have to decide on your own. A proper record looks kind of like this, where you have MX IP addresses and end with minus all, which means that no one else on the ones on this list can actually send emails. And what it adds is a policy. So you have V equals DMARC 1 it's DMARC version 1, P equals none. That is I only want to collect data on this, and the RUA is is where the reports are mailed to. It's an XML format. And don't parse it yourself. There's online tools to help you with that. You can get this status detail from a site called Demartian. You can see the SPF is yellow. Attention needed. That's because I have the plus all, and that's not really. That's not a good thing. It's green, even though the P equals none. No policy is present. The options for policy is none, which means collect reports. You can have quarantine. That means if someone else than those on the SPF list are sending, mark it as spam. Or you can have a reject as policy. That means if anybody else is trying to send it, you should just discard the email immediately. Do we have time for a live demo? Well, we have 10 slides left and 3 minutes, but we can try. This is the Demartian interface. You can see there are some various statistics on the origin of the mail servers, mainly Russia, for some reason. If you go into the volume part here, you can see that it's 24 unknown emails in volume details. You can see sorted by day or where it is, and you can actually expand this as well and see what sending servers are actually doing this, and it's mainly Russian, there's a Chinese, and so you can get reports and see where they are originating from. And you can see that the reporter here is from Google and mail.ru. Yahoo also sends these DMARC reports if you request it, but none of the other major players is really doing anything good in this thing yet, but it'll probably be better soon. The way that the text record is made is this version 1. Then you have the policy. Here you have the quarantine as a policy, and you can set the PCT. That's the percentage of emails that are hit by this policy. So if you want to lean softly into it, you can just start by enabling it and setting it to none to collect reports. And when you're brave enough to actually enable it, you can just set it to 1%. So only 1% of your emails is actually being treated by this. And if you have a large environment, it still may be many emails, but you'll get a better idea. And when you are feeling brave, you can set it to 5% and 30% and 100%, and then you can change the policy from quarantine to reject, and do the increasing of the percentage again from 1, 5, 30, whatever. So DMARC is sender policy framework plus DKIM and a policy. I'd recommend that you look at demartian.eu, run by a really nice guy. You can it's free for personal use. So if you have just a couple of domains, just put them in there. You can get the good reports. And there's also a list of. Actually, I forgot to show you that. You can here, if you go on the domain list. There's tasks and issues as well. So here you can see that I have a domain, github.dk. It needs DMARC to be added. And there's an issue, which is that github.dk doesn't have a SPF record at all. So it also helps you through the process of actually enabling DMARC for your domains. That's pretty handy if you're somewhat unsure of the process. But use these two tools. DMARC, as I said, free for personal use. If you're a commercial user, you can pay a bit for the service, and I do that for where I'm currently at. Also, there's hardnize.com, which is a generic tool for hardenizing all of your infrastructure. Also, it checks your TLS setup and stuff like that. It's an invite-only site, but ask for invites. They're pretty fast to let you in. Things that aren't covered in this talk is DNSSEC, DAIN, MTS, STS, and TLS reporting. You can look that up for yourself. And there's like 45 seconds for questions if you have any. Yep. It's true, there is a problem with mailing lists. I think it's a matter of pushing them to doing it because DMARC is merely the policy of enforcing Standard Policy Framework and the KIM in one tool with reporting as well. So it's true that there is a problem with mailing lists in particular, but there isn't really a lot of commercial users using like mailing lists, and there is a workaround for that as well. If there's any more questions, I'm in the first of the caravans after the info booth. Feel free to drop by and talk.
I would just comment, I'm doing a talk on Sunday on specifically how to do this for big mailing lists in systems to improve your deliverability.
Great. Yeah. Thanks.
Hello, I'm a first-time presenter, so this will be my experiment, is to talk consistently into the microphone. All right, so this lightning talk is, I'll give you the TLDR, is I used to spend a lot of time on Exercism, which is exercism.io is a learning project for like, you can learn programming languages, and I think they have like more than 50 languages you can learn. And they have some structural problems, but they have a mass momentum. And I want to know if there's better ways to do it where you overcome some of the scaling problems. So this is a call to investigation. If anyone is curious about collaborative learning platforms, are there ways where we can use decentralized systems like Git when the subject matter is going to be programming anyway? So maybe for some learning material, Git would be a showstopper because it's a difficult thing to learn. But specifically for programming, that might not be a problem at all. In fact, it might be a benefit. So I'm going to start by saying, I think in 2018, I started, I thought maybe I should try and learn OCaml. And I already know a very similar programming language, so I thought maybe I can learn the dialect part, like maybe I can transfer my knowledge from one language to the other if I just complete a few exercises. It's just like to get to know the syntax and do a few problems and realize what are the differences like in dialect. And I think exercism was really great for that, because I signed up and I went through 10 exercises where I got custom feedback from someone who probably had more experience with OCaml than me. And the waiting time was maybe a day between each handing in an exercise. I got feedback within a day. And I thought this was fine because I could just do side exercises, I could just brush up on other things, but eventually I got a bit bored waiting, so I thought I'll just open another track, like another language that I'm familiar with, maybe I like it even more. And that track had, that was the Haskell track, that track had even worse performance. So maybe the average waiting time there was a week before I got feedback on a simple exercise that might have taken me 5 minutes to complete. So this was very dissatisfying, so I decided, okay, maybe I'll just become a mentor on that track, and then I follow the other tracks. So I'm learning something and I'm giving something, and that is only reasonable because, I mean, I get other people's time for free, I should give some back, right? It's like questioning and answering on IRC channels or whatever. But the burden was just so big. So I basically kind of quit learning OCaml, and I just became what the role is called a mentor. So you have 3 roles, like a student, a mentor, and a maintainer. So there's a part of the infrastructure for each language track. For example, what are the exercises for this language? That's one role in the system is to maintain those. Another one is to give feedback. So feedback is given on the website that is developed in, I think, Ruby on Rails or something. And the organization, Exosystem, the organization has kind of a bottleneck because they are not a free or open source software project, but they're a non-profit NGO that uses open source and free software to kind of reach their goal of kind of programming education for everyone or something like that. But because the organization is running and reproducing the website, fixing bugs, extending the interface for when people deliver solutions, and the feedback interface for mentors is on the website. This kind of, because there's very limited amount of hired programmers to do this, then the development here has to be kind of angled and very prioritized, and they don't accept a lot of outside help, because managing people's code for this, they kind of assess is kind of, they would end up spending more resources cultivating the type of development they expect. So this part is not really open sourced. It's open sourced, but it's not free to contribute to. And I think that's like a massive problem, because one of the bottlenecks is you don't want to have to wait. So for example, for the Rust track, if you hand in your solution to some kind of hello world like problem, the average waiting time would be 2 months before you get feedback. That is enough time for you to completely have either quit learning the language, or have found some other source of learning it, right? You don't want to wait 2 months between like very simple assignments that take maybe 10 or 15 minutes to complete. So of course Exosystem has addressed these problems by trying to automate some of the feedback mechanisms by making auto graders, and this is a massive effort, because every single language has to build the exercises from the bottom up with these in mind. Some languages don't have the same infrastructure for parsing itself and doing syntax trees. So for example, languages like C#, this is really easy because you have a compiler support for that, and Python I think is pretty easy too. And you also have an abundance of people who want to do that for those languages, but maybe for Perl you don't have the same luxury of a lot of people contributing hours and hours of work. So this is some of my experience with the platform. I think it's an excellent platform, and it has some bottlenecks. And also the last thing I would highlight from having experience with it is, when you contribute, you get access to a website where you can upload a file, and you get a command line tool where you can upload it using the command line tool. So if you're writing in your solution in a file on your file system, you can use that command line interface to upload your files. This is really smart, but it's also kind of a simulation or an approximation of a similar commands you might use as a real developer using Git or something similar. What I think is maybe make that part more realistic, because you're gonna learn to do that anyway. So why create like a separate ecosystem only for simulating real work? Why not use Git to fully leverage the decentralized aspects of this platform? And having kind of pointed out at least most of the scaling problems in terms of there's not enough mentoring capacity, and the software infrastructure for the Exosystem project also has some development bottlenecks. One direction that I would propose is to look at something like Github Classrooms, which is something that was released by GitHub this year, I think, which is kind of like intended for school systems, that they can create organizations and projects and assignments, and you have these entities inside the GitHub Classroom system, and then work from there. See if GitHub is enough, or if we want to kind of take it even further, go more decentralized, and basically reinvent this kind of collaborative learning where everyone is kind of connected as a node in the system. I will be spending a bit of time doing this today, and if anyone is interested in collaborative programming platforms, growing them, using them, come and talk to me, and maybe you have some good ideas, or maybe you have a completely different experience report. And I would also like to hear that. So that concludes my talk.
We do have time for a question. Where will we find you?
Here, after the thing. And also, I have a workshop tomorrow called Solving JQ Problems. And this would be a good place where we can kind of bootstrap, for example, GitHub Classrooms, because it will be a workshop and it would be possible to use GitHub Classrooms. So at least the next time I'm on schedule is in that workshop. But otherwise, immediately after the lightning talks, I'll be around.
This is very unprepared, but this 2 or 3 days ago, last weekend, we us two and one more semester from Denmark, we were competing in the DevCon finals this semester. Oh, there it is. Where is it? Hello. Yeah. Okay. So. Okay. Okay, yeah, can everybody hear me? Yep. Is it great? Good. Okay, so this week, just before Bornhack, me and my friend, we were playing in the DevCon finals, CTF, the team Norse Code, which is a collaboration team between all of the Nordic teams, CTF teams, the best teams, so Hacken for Sergio and Boot Plugs and on, collaborate on competing in, the hardest CTF competition ever. And we're going to talk a bit about that, and we actually hope that you have mostly questions for us about how it is. So it was an A&D CTF, which means everybody has a server, and then we are trying to hack each other's services, and there is no SLA, so there's no machine checking if the binary is correct, or you just passed everything, patched the service out. You didn't have SSH into the vulnerable box itself, but you have this form, maybe a bit hard to see, but it's here you can submit flags or create an auto submitter based on it, and then all the challenges get released here, and you get PCAPs from all the servers. And here you could also submit patches, because if you find a vulnerability, start setting one team, go, start making an exploit, and then you have another half of the team, go, make a patch for this. And then you were very limited in how these patches could be applied. So often you could, at most, edit a few hundred bytes. So you really had to patch in the binary, and of course, in these kind of challenges, you don't get the source code. So yeah, you only have like the binary format. You have to reverse it, and just to kind of peek into how extremely hard are these challenges. So one of them, the first, was like a parallel operating system built completely from scratch, and also a custom architecture. So it was a binary file that like that ran as a VM. On top of that, there was some services running inside of this custom VM, and it was all written in a custom architecture you never seen before. And also the OS was still like dynamically loaded files like from ELF and so on, but a completely custom OS and architecture. And then you had to like reverse these and find the exploit in these pre-installed files. So you really had to reverse an entire virtual machine from scratch, and you have like 8 hours or so before the shift ends to do this. So that is the kind of level we're talking about here. And we have also brought some images. I just found them here. If I can get my mouse over here. Okay, I can take this. Oh yeah, this is also very good. So that is kind of like a what we call Venus plug. So that is an overview of all the teams, our auto flag submission system. We just like put a Python script and it just prints out flags in std out, and then this system would automatically like find the flag in all of these logs. Here it's like our runners, so the scripts that we run. And here we can see all of the other teams. We got 10th, by the way. Yeah. A competition of 16 teams to the best in the world. Yeah, 10th in general and 10 in attacking, which is the most important thing. But yeah, we also had some practical stuff. So as Alexander said, we met in Stockholm with all the other people from the other teams, and there you can we also have some photos here. One of the challenges was a capture the flag. No, King of the Hill. Sorry, King of the Hill challenge, where you had to create an AI that was to compete with the other people. So you upload your AI, and that controlled a little ship that had to shoot all the other ships. Well, it wasn't only that simple, because they had also put in some intentional bugs in the code that actually ran this. So it had a buffer overflow. At least that's the one we found, where you could actually extend. So you were able to extend the space and override some of the checks for the size of this AI, so you can get a big AI with that was better at attacking the other people. And here we have a little photo of everybody standing around the same screen, looking at the small planes flying around and shooting each other. That's 5 minutes. Right, and then we have other pictures here. Oh, and I had those here. Yes, so this was the venue we were sitting at, and we were at the venue. We were 20 people, and there were about 5 to 10 at their own homes on Discord helping us, but maybe a bit more. But it was mainly the people at the venue we like. Yeah, we interacted with, and it's also a bit easier when you're just sitting in the same place to help out on. So this was like big event. So it was like state sponsored for the police and the government. This competition. We had all the food and everything we needed. Everything was just sponsored. So it was no time to make pizza. Someone brought it. Yeah, that's also one of the lessons learned. So we had booked a hotel close by that we did not use at all. There was like you had to be ready if anything happened, and also like spending those extra 15 minutes walking back and forth is it's time wasted. Yeah. So it's really time intensive. Yeah. You just have to be there all the time, get 4 hours of sleep at most, and then back home. Yes. There were downtime in between when you couldn't harvest flags from the other teams, but
but then you still had the binaries, and you're still able to reverse engineer those still. So there were you really had to choose when to go to bed and when not to.
So it was structured in shifts. So it was like when the server gets up, you get 1 hour to set everything up, and then after that hour it starts. Then the flags starts coming in, and every like 6 minutes, there's 6 minutes with one tick. Every tick there's a new flag on the server. So every 6 minutes you can like go get another flag with the same exploit, so then have this time. Really, that's the most critical time span where the server's live. Then it will like after 8 hours or something, then it will go down and say, okay, now the server's closed. Now you can reverse engineer, you can start making patches, so everything's ready when next shift starts. And at the beginning, at each shift, it's like there comes some new challenges, and you will just have to be quick.
And the other teams are very, very good, like really good. For instance, we had one like module. It was a module written in Node.js, and it had some bugs in it. And the best team, like no, they didn't actually win, but the ones that were leading the most of the time, they got a flag in the first tick. So within the first 6 minutes, they had a working exploit against it. And then you're really like, okay, now we also have to find something because they're harvesting flags, at least trying to patch it or something like that.
It's extremely hard competition.
Yeah, and the other teams are extremely good.
So yeah.
So yes.
Any questions about being at the event? Yeah.
Yeah.
No.
Well, no, but there were PCAPs given by the game. What's it called? Like the game network.
So the game server. There was like this instance that run all of the servers. So we were also getting PCAPs from all of the other teams, or kind of. There are 2 ports you could attack on: one stealth port and the normal port. If you hack on the normal port, you get full points, but everyone can see all the traffic on the normal port. Stealth port, half the points, but there is no PCAP released. So you kind of have to decide whether or not you want to stealth this or not.
We also there was some of the challenges was solved because of the PCAPs. But definitely. But many of the good teams, at least, of course, like sends a lot of bullshit with the actual exploit.
What?
No.
You could snip.
But we didn't. Yeah.
Snip every packet.
No.
They were just released to us, and then we could go through it. And that was a lot of work. And it's like a really big meta game because you could also submit patches, and the package for patching your vulnerability, that's also exposed. So people can go like just if they can figure out how this patch works, just go and copy it, and you can of course backdoor the patch.
Cool, let's give a round of applause.